Alright, Algebra 2, here we are with section 5.2, day 2. This time we're doing synthetic division. A little bit of a shortcut for you, a little math magic going on. Okay, so yesterday we looked at doing polynomial division with binomials. Alright, we went through this whole process, comparing the fronts. 2x to the third divided by x is 2x squared. Multiply it back. Okay, subtract down, bring down your next term. Compare the fronts. Negative 5x squared divided by x is negative 5x. Multiply it back. Okay, subtract down. 26 minus 20 is going to be 6. Bring your next one down. Compare the fronts. 6x divided by x is plus 6. Multiply it back. Subtract down. No remainder. Okay, that's a lot of work and takes up a lot of space on our paper. Let's see if we can come up with a shortcut. Well, we won't see. I'm going to show you the shortcut. Okay. So step 1, we look at what makes what we are dividing by 0. We're dividing by x minus 4. What makes that equal 0? Positive 4. We're going to put that in a little half box right here. Then we're going to use all the coefficients of the dividend, what we're dividing by, or what we are dividing. 2x to the third minus 13x squared plus 26x minus 24. So we're going to use 2, negative 13, positive 26, negative 24. Then we're going to leave an empty line, and we're going to draw a line underneath. Okay? Step 1 from here. And I'm just going to go through all of these like individual steps. You could probably just do this all on one line of paper. Because if we did these all separately, step by step, it's going to take a full page to do a problem. Okay, but I just did it all separately, step by step, so that you could see each individual piece in super slow motion. Okay, but if we were to do this as one problem, it would just be like right here. All on these two lines of work. That's it. Okay, so step 1. First number drops straight down, so the 2 just drops straight down. And whenever we have a number on the bottom, we multiply this number on the bottom by the number up here in the little box. So 2 times 4 is 8, and I put that underneath the next number. Okay, so negative 13, then I have an 8. Alright, so freeze frame there. This 2 drops straight down. First number always drops straight down. 2 times 4 was 8, and I put it underneath the next number. We're getting ready to add down. Okay, so 2 times 4 was 8. We're getting ready to add down. So I add down. Negative 13 plus 8 is negative 5. Now we have a number under the line again. Whenever we get a number under the line, we multiply by the number in the box. Negative 5 times 4 is negative 20, and I put it in the next spot. Okay, so we put negative 20 there. Add down. 26 and negative 26. We have a number under the line. 6 times 4, 24. Add down, 0. The last number at the very end is your remainder. We got a remainder of 0. Okay, now look at this. I have a 2, a negative 5, and a 6. You can think of it as working backwards. Numbers, x's, x squareds. 6, negative 5x, 2x squared. Or we can go forward from 1 power less where we started at. We started with 2x to the third, 13 minus 13x squared, 26x minus 24. So I started at x to the third. So my answer now is going to be with an x squared, 1 less. Okay, so this is going to represent my x squareds, x's, 6's, regular numbers. Okay, same answer we had up here. 2x squared minus 5x plus 6, same answer we had up there. Alright, and it looks like, step by step, this looks like a lot of work, but this is what you should have on your paper. You have all this. Okay, I said 2 lines before, it ends up being 3. Alright, so all that process happens on one piece. You don't have to have each individual little thing separately. So this is what you would have done on your paper. Drop down the 2, negative 2 times 4. Why does that look like a negative? Positive 2 times 4, 8. Negative 5. Multiply. Negative 20. Add down. 6. Multiply. 24. Add down. 0. 2, negative 5, 6. 2x squared minus 5x plus 6. There's your answer. Okay? It goes really fast. It's a lot easier math to do than this, and it ends up taking less space. You're going to love it. Alright? So, let's write this one down. 2x to the third plus 3x squared minus 4x plus 15 divided by x plus 3. Okay, so once you get that written down, I'll flip it over here if you want to see like the step-by-step. And you can pause it like right here to see your step-by-step to work through that other one. Alright, let's see how you did. So what makes this one equal 0? Negative 3. Is it x plus 3? What makes it equal 0? Negative 3. That's the number in the box. Then I have a 2, 3x squared minus 4x plus 15. Skip a line, draw a line. First number always goes straight down. 2 times negative 3, negative 6. Add down. Negative 3. Negative 3 times negative 3, positive 9. Add down. 5. 5 times negative 3, negative 15. No remainder. My answer is 2x squared minus 3x plus 5. Piece of cake. Super quick, too. Alright? What happens when there's a remainder and or a missing term? Okay, so we got two new things going on here. Two new little pieces to the puzzle. 4x to the fourth plus 2x squared minus 4x plus 12 times x plus 2 to the negative first, aka divide by x plus 2. Notice that we're missing an x to the third spot. Okay, so when that happens, we're going to put a 0 into our synthetic division. Just like you would have done for the long division, you have to put a 0 placeholder. Okay? So we have x plus 2 to the negative 1, so we're dividing by this. So what makes this one equal 0? Negative 2. We have 4x to the fourth, 0x to the third, 2x squared minus 4x plus 12. Okay, we're expecting a remainder, a leftover. We already took care of our missing term. Drop the first number down. 4 times negative 2 is negative 8. Add down. Negative 8. Times negative 2, positive 16. Negative times a negative, positive. Add down. 18. Times negative 2, negative 36. Add down. Negative 40. Times negative 2, positive 80. Add down. 92. Yikes. But we were expecting a remainder this time because the title there is remainder problem. Alright, so I started at x to the fourth, so I know this is going to be x to the third. Or you can count backwards. Regulars, x's, squareds, thirds. So this is 4x to the third minus 8x squared plus 18x minus 40. Remainder just like what we did with last time. It's a positive, so plus 92 over x plus 2. Okay. Let's have you try this one on your own. Alright, if it helps you to change these to x's, go ahead. Alright, but hit pause here and try that one on your own. Alright, let's see how you did. What makes this equal 0? Positive 2. What's going up on the top row? We got a 6y to the fourth, negative 8. We're missing our x squareds or y squared, so 0, 12, negative 14. 6 drops down. 6 times 2, 12. Add down. 4. 4 times 2, 8. adds to 8. 16 adds down to 28. 56. And we got a remainder of 42. Let's see. Yep, so I got the first time too. Alright. Didn't sound right when I said it out loud, but that's what I had the first time. Alright, so our answer is 6y to the third plus 4y squared plus 8y plus 28 with a remainder of, that was a positive, right? So plus 42 over y minus 2. Okay, moving right along. What if our number is not like a single x? What if there's a number in front of our x and what we're dividing by? Okay? Whatever we're dividing by, we need this to be a regular x. So whatever this is, we divide by 3. Alright. And we get x plus 1/3 now. And then we also have some thirds over here. It's going to look ugly for a while. Okay? But it's easier to deal with these little fractions early on as opposed to having to make adjustments at the end. So what would make this one 0? Negative 1/3. Okay, my leading ones here, my coefficients are 1, negative 5/3, 1/3, and 7/3. Okay, we are also missing our 0 spot, or our regular number spot, so to put a 0 in there. Just like every time here, 1 drops down, times negative 1/3, negative 1/3. This is going to add to negative 6/3, or that would be a negative 2. Negative 2 times negative 1/3 is a positive 2/3. Those would add to be 3/3, or 1. 1 times negative 1/3, negative 1/3. These would add to be 6/3, or just 2. And then 2 times negative 1/3 is negative 2/3. Remainder of negative 2/3. Okay? So if you can kind of do this fraction simplifying in your head, you won't need those. We just want these. Okay? So that is x to the third minus 2x squared plus x plus 2, and we have a remainder of negative 2/3 over x plus 1/3. Okay? Well, I don't like those fractions. Okay, remember what we divided by here? We divided everything by 3 to get those. If I multiply the top and bottom of my fraction by 3, negative 2/3 times 3 is just negative 2. X plus 1/3, both parts times 3, 3x plus 1. So we just end up losing the 3. We lose the denominator on the top, and then we get back what we had up here, 3x plus 1. This is our remainder. Okay, do we need to do one more together? Let's do one more together. Alright, so I don't want this 2, so I'm going to divide everything by 2. So now this is a 4x to the fourth. We'll put the 0x to the third in. 2x squared half x plus 2. And we're dividing by x plus a half. Okay, so what makes this one equal 0? Negative a half. Alright, we have a 4, 0, 1, 1/2, and a 2. That 4 is going to drop down. 4 times negative a half is negative 2. Adds to negative 2. Times negative a half. We're going to get a 1. Adds to a 2. Okay, 2 times negative a half. Did I do some bad division here? Yeah, this was supposed to be a 2, isn't it? That's a 2, 2, 3. There we go. You saw that though, right? You saw that and corrected me. 4, 0. Make sure I didn't do it again. 2, half, 2. Huh. Alright, so that's a 3. There we go. 3 times negative a half. Negative 3 halves are negative 1.5. Okay, that's going to add up to negative 2 halves. Or just negative 1. Negative 1 times negative a half is positive a half. Remainder of 2 and a half. Or if you're a decimal person, 2.5. Fraction person is 5 halves. Okay? So we have 4x to the third minus 2x squared plus 3x minus 1 with a remainder of 5 halves over x plus a half. Okay, we're going to get rid of those fractions by multiplying top and bottom by 2. Now give us 5 over 2x plus 1. Okay, and I'm running short on length here, so we're not going to get to this last one on your own. That's going to have to be it for now, because we are running out of time on my time limit. So, it worked out almost perfect. All right, good luck there, kids. Let me know if you have any questions on it. See you in class.